Hi, this is a follow-up to the overview, and in this part of the lecture series, I'm going to talk about the overall design intent of the thinking machine that I'm proposing. Uh, Mostly, if you research machine intelligence, you'll more than likely end up uh, in a computer science sense end up dealing with neural nets and for the most part, this is how people perceive intelligence in terms of machine intelligence. And there's a lot of good stuff out there on neural nets and how the weights between the connections are managed and the algorithms for that. There's also pattern recognition um, software out there which uses a variety of techniques to pattern match uh, you know, images and forming letters and so on. And in the most part, it works reasonably well, and these systems are pretty effective. Uh, so this design pattern is doesn't discount neural nets. It's just what this design pattern says is that neural nets are part of the solution, but they're not really the key to the. They're not really the key to intelligence. So I guess the idea is that the neural nets are really more like, in this theory, they're more like the wiring kind of inside a chip, like a computer chip, as opposed to the to the ingredient that makes the pathways intelligent. Um, so we obviously live in a world of a Darwinian world where the 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 accepted wisdom is that we have evolved and that our bodies have made these random choices, and over time, some choices work and some don't work, and basically we've ended up with the intelligence that we have, and it's evolved. It's a good design pattern, and uh, to a certain extent, neural nets are seen as kind of an extension of that idea, where the neural nets themselves don't know where the intelligence is, and they sort of manage the weights, and then they figure it out. Now, in this design pattern, we're kind of going to step up a level above that way of thinking, and what we're going to do is I'm going to discuss a variety of ideas, and I'll build on them to build this design pattern. The first idea is, in an intelligent robotic system, I'll have what's called the window in the mind. Uh, so the idea is pretty simple. Uh, it's that when one opens one's eyes and sees the room that one is in, the mind is creating that room for you and placing you inside it as a person or whatever you. It could be an ant, it could be a person, it could be any kind of living being. It could be something at the bottom of the ocean. It could, and it doesn't really matter. It could be anything, anywhere, using kind of our DNA based approach. Um, so one gets the sense of the room one is in or the place one is in, and it feels very real. And the two parts of the mind, the internal vision, the internal picture that one sees, is a pretty good approximation of what's outside the body. So I call this the window in the mind. And inside that window in the mind, I'm going to flesh out what's what's that about? What's that window mean? So we end up in a situation where we end up in some kind of a physics-based reality, which mirrors the real world, and the brain kind of helps one approximate the behavior of the outside world compared to the one that the brain is building for us and placing us inside. So the idea of this design pattern is that the self is a construct in the mind. The brain constructs a window in the mind and places one inside that window. So it's pretty simple. I have more detail later, but that's the basic concept. Um, I also have a physics engine that I've worked on. The idea being that the place that one is placed inside has rules in terms of how things move and so on, which is really a physics based environment. Um, but the idea is that it doesn't have to be a PySpace physics engine. It could be any physics engine where if you throw something, you can predict what's going to happen and so on. I'll talk about that more later. Um, as I've already said, we our DNA is a reasonably new uh, technology. It's moving very quickly at the moment at the time of writing, but we pretty much know that the DNA is really the um, the program, if for want of a better word, for how our bodies are built and so on, and how we're built and how evolution occurs. Um, a little bit controversially, um, uh, uh, the this theory would assert it, it's not really a scientific assertion; it's more of a personal assertion that the DNA itself has a messaging mechanism, which can inform the DNA of how to improve itself. So it's not running against the idea of evolution. It's not saying that evolution isn't real. It's saying that the that the DNA contains a messaging service, a very advanced messaging service, which can generate messages back to the DNA in order to tell itself to improve. I'll talk about that later, but uh, uh, that the idea is that the body sort of knows when something's not working, and it can in some way message the itself, and then can encode those messages back into the DNA for future generations. So another core part of this design pattern is messaging. It's really important. So it's one of the key, apart from a virtual self existing in a window in the mind, and then the mind, uh, producing this room. What's really important to understand in this theory is the messaging algebra is so fundamental to the whole system. So when we think of any kind of life form according to this theory, we're not just thinking about neural nets and the physical form. What we're thinking about are the different various message types that flow through the being, whatever it is, and the algebra that gets applied to it. Sort of like operators. So we have message types and we have message operators, and as they interact with each other, we get this idea of a message algebra. And this is how the DNA uh, produces, stores the rules of these messages, and then helps build the body, and then the messages flow around the system. So if you think of any being, including say yourself or myself or whatever, according to this theory, uh, really what's really fundamental to this design working is that the body is messaging itself in a variety of ways, which I'll go into later, and those messages mean certain things to certain cells. So we have cells in the body, and they have different kind of roles. I'll talk about that later. So we have the virtual self. We have placed in a window in the mind. We have some kind of a body made of DNA, which has some kind of messaging protocols, and then we have DNA containing these kind of what I call later on apps. Like an app store, and the DNA, the cells will have certain apps turned on, and they'll have certain apps turned off. So this is kind of trying to view DNA in a kind of the way that a computer science engineer would see it. So I'll talk about how the cells have these services that they can turn on and off, and how it's phrased in science journals, and I'll talk about um, how that works. But that's sort of the idea. I'm just going over the high level ideas at the moment. Um, so the other idea, which is probably a little bit controversial, is that uh, and you know take it as it is. It's just an idea. It's that a human being runs on some kind of an operating system. in the same way that a machine runs on an operating system. So that's a concept in the document. I know people may not like that idea, but and I'm not saying we're machines. I'm just saying there is some kind of operating system which has a message algebra and zones of specialized behavior, as I say. But the basic idea is that the body works according to a set of rules, a rule-based system that's encoded in the DNA, and there are messages flying around, and there are cells, and then there are certain ones switched on and off depending on what type they are and when it is. And basically, I call this the HOS, right? OS being operating system, so it's a human operating system, HOS. That's what I call it, the human operating system. Uh, so that's a concept I have. I may talk about the HOS um, later, but it's human operating system. An important point on the document is, you know, I realize that people get kind of funny ideas about machines. You know that there's a lot of movies out there where machines do terrible things. So the idea of the design is not to encourage people to build killer robots. The idea of the theory is that if people who need to make objects intelligent have a framework where they can do it in a socially responsible way, and it's up to politicians and society in general to figure out what is acceptable and what is not acceptable. So the idea of this document is not to help people build up some killer robots, okay? The idea is to help people um, make life better, you know, in whatever way that makes sense. Okay, and that's an important point. It may sound a bit sci-fi, but you know, if you really do want to take this idea seriously, you really do have to think about these things. So that's the idea. The idea is to improve people's lives in whatever way and for it to be socially responsible. But like if you drive a car, if you drive it responsibly, it's a very good thing. If you drive it irresponsibly, it isn't. So, moving on from that idea, the idea in the long run would be to have some kind of software prototype. I don't have one at the moment at the time of writing, but the point is that the design is really the important thing. Once the design is there, the software will follow. I will talk about the potential software design that's required and how it could be achieved. But for now, I just want to explore the design ideas and patterns and what makes sense. Now, the other thing is, in computer science, people don't typically get taught medical stuff. We tend to have people who in medicine they learn about the body and they learn all the terms and they learn all the the different wiring diagrams in a body and they have all these amazing names for them and they have all sorts of stuff like that. And then you go into computer science and you look at maybe a board on a chip, a motherboard, and you see wiring and so on and power circuits. But I haven't been taught in medicine, so I've had to learn this as I go. So that means that I'm going to probably make a mistake here and there. Okay, I'm not a doctor. I'm not a medical person. There are probably medical people who might hear this document or read this document and have a bit of a chuckle. I'm not a medical person, but I'm a science person who wants to understand medicine, and this is my best attempt at learning it and applying it. So there will probably be mistakes in the document, either in terms of terminology or whatever. But the point is, I'm trying to reverse engineer it, right? So there will be some things I'll get wrong, but the point is I'm trying to understand how it works as opposed to the naming conventions and the wiring diagrams and so on within the body. So please, if you know more than I do when you're listening to this, please bear that in mind that I had to learn this as I went along. The point being, it's a kind of like a base document that you can build off in order to maybe improve your own knowledge if this is your interest. Um, and so obviously I'm going to maybe do some open source software. I've done a little bit for the physics theory. I may improve it over time. But then I'll move on to the terminology. This may change over time, but these are the core terms. There's the it's OZ really, HOS, but I say HOS, HOS or HOS. AOS, HOS is Human Operating System, AOS is Android Operating System. And then we move to a really important system, part of the way this whole thing works is, and I haven't talked about it yet, but I will now. Basically, if you have a body that has a brain of some kind, a central nervous system coming to a point. All the messaging goes through through that part of the body. So I call that area that processes all the messages and accumulates them and pairs them and so on. I call that the SC, the system consciousness. So it's a bit like a kind of a message accumulator. You know, so many bits or messages per second, and then you have the sub SC, which is the bit that has the all the messages and with certain ones not filtered out. And then I have the SCGC, which is the System Consciousness Graphics Card. So basically, I think of consciousness in this design pattern as a kind of like a message bus of messages flying through the brain of various types and to do with various tasks. So think of it as consciousness as the flowing of messages around. This is I'm not saying that this is a kind of technically correct. I'm just saying this is the design pattern that I'm going to do, and this is what I mean by system consciousness in this document. So you may have read different definitions for consciousness, but in this document, this is what consciousness means. It's a kind of a message flow through some kind of a body, and then it accumulates at a certain point. And then there's the SC or there's the reality room. These are the messages can flow into certain kind of rooms in the mind. Then there's SCPPR. So this is the system consciousness predict plan room. So that the idea is, for later on I'll describe it, where you can have you can think about a problem and you can formulate what it's going to look like before you've built it. So I've formalized how does that work. I have the concept of rooms in the mind, windows in the mind, different rooms, and how you can switch in and out of them. I have the HMIC. That's more of a well-known term. That's a human-machine interface term. And then HOSL, and I call that HOSL. So it's a human OS for language for messaging. So that's the whole messaging stack. That's all the message types, and that's the HOSL. And then there's the OSL, which is the operating system message language for the Android. So the idea is I come up with a general kind of framework for the messaging, and basically I sort of talk about the different message types a human being has, for example. But later I talk about spiders and I talk about all these different kinds of life forms. I talk about ants and I kind of explain that if you just apply this pattern to these beings, you get this different view of them. And then I'll talk about then I'll try to reverse engineer that into this Android design. But again, I just want to say it's not just about building an Android. It could be a plane that is really smart when it operates in the air. It could be a ship. It could be anything. It could be your refrigerator. You know, and that may sound a bit silly, but you know, if you could put some kind of smarts into a fridge or a washing machine or whatever, you know, you don't have to put the whole solution into you know, you don't want to end up in that kind of Douglas Adams reality where the door is super intelligent, but you know it's just become annoying. I'm talking about something where you put only what you need to put into it in terms of the messaging protocols. So finally, I'll end on the definition, uh, which is the what is life definition, and I mean that in terms of what is intelligent life, what is the thinking machine, and the definition is pretty simple. It says that which contains internal and or external messaging paths with different distribution models and strategies for evolving actionable message types and physical forms to achieve necessary goals. So it's a bit of a mouthful, but basically messages come in are internal or external. Um, the messages can be distributed in different ways. I talk about things like spiders, how do they do it, and then the strategies for evolving actionable message types. So the idea is that the message types aren't static; they evolve over time, and this is the whole Darwinian thing. And then the physical forms vary from one being to another. So we see DNA builds different shapes and forms. You know, for if you're digging through the earth, you'll end up looking like a worm. You know, but then you only need a certain type of message structure for that. And then the other part of the design is really important, and I haven't really touched upon it, but it's really important. It's the goals. to achieve necessary goals. And that is no matter what anybody does in any walk of life, or any being, or any ant or cat or dog, every living being has some kind of goals, and that's what drives the the being to do whatever it needs to do. And so the idea is that we have that's defined in the document, setting out the goals for what the being should do. Not like if you're a fridge, keep the food fresh, and so on. So, and if you're a fighter jet, then yeah, be a good fighter jet. Uh, um, so those are the ideas. So that's the definition, and that's where I'm going to leave this recording.